In lesson 4, we're going to be talking about more examples of functions and basically a couple different types of functions, either being a discrete function or not discrete function. Okay, and so I'm just gonna give you kind of an introductory on what that means being discrete. Okay, so let's start with our definition. Okay, so discrete. Okay, now when we say discrete, we mean individually separate or distinct, basically integers. Okay, so discrete functions occur when our input values are integers. For example, if I said bags of candy, you're not going to go to the store and say, hey, I want to buy this bag of candy, but I only want half of it. So let me just rip it in half. No, you have to buy one bag of candy or two bags of candy or three bags of candy. Excuse me. So that would be a discrete function because you can't break things up into fractions or decimals. Integers, right? Positive and negative whole numbers. Okay. Then we have, let's try again. Another text box here. And we have not discrete. And that's when our range of values includes decimals and fractions. Okay, so I'm trying to think of a good example there. Maybe like temperature. Is it go directly from 80 degrees to 81 degrees? Nice to have some warm weather, wouldn't it? Or can it be 80.5 degrees? Or think of taking your temperature, right? 98.6, 100.4. So I'll just put temperature down as example. That one, in that one, you can have fractions and decimals. So that's why we say things aren't discrete. So our first example here is we're just going to go through a bunch of lists of things and we're just going to classify them as discrete or not discrete. Don't stress about it, but I want you to be introduced to this term because you're going to run into it later on. Breaking things here. All right, so the directions to say classify each.
Hello.
Jack, want to say hi? Say hi again.
My name is Jack, and today I'm making a Minecraft song. If you're a fan of Minecraft, I'm making a Minecraft song is gonna be called I Need Diamonds, and it's gonna be on mobile.
All right, thanks, Jack.
See ya. Bye
All right, sorry. So classify each of the functions described below as either discrete or not discrete. So discrete, they're distinct integers. Not discrete, we can have like decimals. It's kind of continuous. So the function that assigns to each whole number the cost of buying that many cans of beans in a particular grocery store. So we're buying cans of beans. Can we like cut it in half or cut a quarter off, whatever we need? Or do we have to buy 1 can or 2 can? Yeah, I'm hoping you're saying we have to buy the number of cans. You can't, only take part of a can. So this would be discrete. Okay. Now, the next one says the function that assigns to each time of day, on one Wednesday, the temperature of Sammy's fever at that time. So mom's recording Sammy's fever at that time. So is that discrete? Well, can you get a decimal as a temperature? Yeah, it's kind of what we talked about. So this would what we'd say is not discrete. There's nothing wrong with it. It's just not a discrete function. A function that assigns to each real number its first digit. Well, if it's a real number, real numbers include all fractions, all decimals, all ratios, basically all the numbers that you know. Okay, there's real numbers, there's not real numbers. So we're gonna say not discrete. Now, the function that assigns to each day of the year, 2015, my height at noon that day. Well, we're talking here assigns to each day. Here we're talking to each real number. Here we're talking to each day. So my height isn't necessarily a whole number, but each day is. So I know that's a little confusing. That's why I don't stress about this stuff. We're just kind of going over it here. This would actually be discrete. Just introducing you to it. All right, a function that assigns to each moment of the year. Well, if we're talking each moment of the year, that's not discrete because it's not going to happen like every hour, okay? Be broken up to minutes or seconds, so not discrete. And a function that assigns to each color the first letter of the name of that color. Well, if it's each color, we're not blending colors, okay? It's red, blue, green, purple, whatever. That would be discrete. And the function that assigns the number 23 to each and every real number. Well, again, if we're talking about real numbers, that's all fractions, decimals, all of those types, basically all the numbers we know, like even numbers like pi, right? That's not discrete. A function that assigns the word yes to every yes, no question. Well, that would be discrete, right? There's no overlap. It's either yes or no. And that a function that assigns to each height, directly above the North Pole, the temperature of the air at that height at this very moment. So, let me try that again. To each height, well, remember heights, you're not going to go from 5 feet to 6 feet, right? You can be 5 feet, 3 inches, 5 feet, 11 inches, so that's not discrete. Okay, so again, I just want you to start thinking about, our focus is going to be on input values, okay? And we'll get to that in a little bit. But let's just do one more example here. Water flows from a faucet into a bathtub at a constant rate of 7 gallons of water every 2 minutes. Now it says regard the volume of the water accumulated in the tub as a function of the number of minutes the faucet has been on. Is this function discrete or not discrete? So let's first start by writing a linear equation. So we're going 7 gallons for every 2 minutes. And we set that equal to y over x. And then we do our cross products, right? 2 times y equals 7 times x. And we want to always solve for y. So I'm going to divide both sides by 2. And I'm going to get y equals 7 divided by 2 is 3.5 times x. Now, again, if you match things up here, y represents the number of gallons that are going into this bathtub, and x is the number of minutes. Okay. So, is this function discrete or not? So we want to focus right here on x, right? On the number of minutes. Now think about if you are filling a tub. Does it run continuously, or do you drop in a whole bunch at 1 minute, then drop in a whole bunch of 1 or 2 minutes? No, that doesn't make sense. It's going to keep going, right? So it's not just going to happen every minute. It's going to happen at 1 minute, 1 minute, 1 second, 1 minute, 2 seconds, all the way up until you get to 2 minutes. So if it can be broken down or continuous, we're going to say that this is not discrete. Okay. And then, you know what, we want something else we just want to throw out there too is, let's talk about some limitations. I mentioned in an earlier video that with functions we start putting some limitations on the numbers we can put in or get out. So let's think about our minutes, right? Are there any minutes, like any numbers that we could put in for minutes that wouldn't make sense? How about negative numbers, right? Okay, does it make sense to have a negative number of minutes? No. What about gallons? Does it make sense to have a negative number of gallons in the bathtub? You're going to take more water out than you put in? No, that doesn't make sense either. And so we're going to say that both x and y must be positive. Actually, I got to amend that. Both x and y, we'll say positive. The reason I kind of hesitated, because you could have 0. Maybe I'll put that in here, including 0. 0 is neither negative nor positive, but you could have 0 number of minutes and put 0 gallons of water in. Okay, so you'll notice again, we're not doing anything different, but we're diving more into the types of functions that we're going to deal with.